putting all of this together, our goal is to take this system of three equations, translate it into an augmented matrix, manipulate that augmented matrix to write it in row echelon form, that upper triangular form. And once we have that form, our solution to the system will become fairly self-evident. To start off, we can translate this system into an augmented matrix. And then look at our process for how we'll manipulate this system to get to that goal we want. Our first step is to look at our first row, first column. We want that value to be a 1, which in this case is already taken care of for us. So we can move on to our next step, which will be to turn every value below it into a 0. That means we'll have to look at updating row 2. And in order to turn that 2 into a 0, we can take all of our values in row 1 times -2, and then add that to our values that we have in row 2. This means that everything in row 1 will remain completely unchanged. Everything in row 3 will remain unchanged. And we just need to look at updating our values in row 2. Again, what we're doing is taking -2 times our value in row 1. So -2 times 1 would give us -2, and then adding that to our value in row 2, which in this case would give us that 0 that we're after. Now taking -2 times -3 would give us -6, plus 1 will give us 7. -2 times 4 will give us -8, plus 1 will give us -7. -2 times 21 will give us 42, plus 7 will give us -35. So just to clarify, that should be -2 times 21 would give us -42. So we've achieved our first, actually 2 steps. Row 1, column 1 is a 1. The first value below that is a 0, so now we want to continue that pattern. The next thing to do is to turn this -3 into a 0. In order to do that, we'll update row 3 by multiplying all of our values in row 1 by 3, and adding that to our results that we already have in row 3. Row operations are going to involve rewriting our matrices sort of over and over again, but in each step taking relatively simple steps to update and manipulate our matrix. We're going to take +3 times our values in row 1, so this would give us +3 plus -3 would give us a 0. We'll take +3 times -3 to give us -9, plus 2, which would give us -7. Our next value would be 9, and then 43. Now what we want to do, since we have our first column taken care of, we have a 1 and everything below it is a 0, we want to look at row 2, column 2, and how to turn that value into a 1. In this case, what we'll do is update row 2 by taking 1/7 times all of our values in row 2. Keep in mind, we can multiply by any non-zero number. So this is going to become, let's see, our 0 will remain unchanged. Then this will become 1, -1, and -5. and we haven't updated row 3 at all, at least with this step. But now we will look at updating row 3 because we'll want to turn that value below our 1 into a 0. In order to do that, we'll look at updating row 3 by taking 7 times our values in row 2 plus row 3. So we'll get 7 times positive 1 in row 2 added to negative 7 will give us that 0 that we're after. And then our remaining values will become 2 and 8. Which brings us to our next goal. We want to convert that value in row 3, column 3 into a 1. And we can do that by updating row 3 by multiplying all values in it by 1/2. So the zeros are unchanged, but then 2 times 1/2 will become 1, and 8 times 1/2 will become 4. Meaning we've now achieved that upper triangular form with all of the values to the left-hand side of our vertical bar. And we have our 3 equations, which we can use to now identify each of our solutions. We'll start off with equation 3. So the information in equation 3, or in row 3, tells us that equation 3 would be 1 times z, or just z equals 4. This means that if we've successfully converted our matrix into this row echelon form or upper triangular form, this last line will always give us our equation, or always give us our first solution. From there, we can use a process called backward substitution. So we work our way up to equation 2. Which will be y minus 1 times z, where we know that z is now equal to 4, is equal to negative 5, and then solving for y would give us negative 1. And then working our way up to equation 1, we would have x minus 3 times negative 1 plus 4 times z, which is 4, would be equal to 21. And then solving for x would give us x equals 2. So we achieve that ordered triple, xyz, which is going to be equal to 2, negative 1, 4. So this process will become quicker as we start to get more familiar with how these row operations work. We'll look in our next example at how we can combine steps, apply multiple row operations at the same time. There will be sort of this process of rewriting our updated matrix over and over again. But again, all we're doing in each step is applying a few simple arithmetic operations, or maybe just changing the position of 2 rows, but achieving the same result, coming up with those, in this case, 3 values that would make all 3 of our original equations true.